one book, Hacking the Art of Exploitation by John Erickson. I
Okay.
consider that to be a Bible,
Yeah.
Oh,
and
do you have it
it
on your
goes over. Sorry?
do you have it on your
Oh,
nightstand?
yes, I do.
Oh,
It goes over from really basic to really complex stuff. So even if you are really new to the industry, you can learn on like no matter where you are on your journey, you can always learn something from that book. It's a really old book, but still applies to a lot of concepts right now.
Welcome to The Elephant in AppSec, the podcast to explore, challenge, and boldly face the AppSec elephants in the room. I'm Alexandra, your host, joined by my amazing co-host Tristan, a former security engineer and co-founder of Escape. Today, we are excited to have an amazing guest, Malav Vyas. Malav is a security researcher at Palo Alto Networks, passionate about exploiting and securing systems. In our latest episode, we challenged Malav about whether APIs introduce more security risks than benefits to SCADA systems, how hard it is to secure them, and what their key future challenges are. Dive right in! Hi Malav, very excited to have you today on our podcast, and thanks for taking the time to talk with us. Very excited about the topic. As I mentioned before, we'll talk about SCADA systems today, and I think it's something we already discussed when we met before to talk about the podcast. But I think few incidents in the SCADA world actually left such a big mark as it was for Stuxnet malware attack. So I think if we go back in the early 2010, if I'm not mistaken, it was not
Right.
just any malware, but it was actually developed by the governments, the US and the Israeli, intelligence service. And it was operation called Olympic Games, so very special name. The goal was to manipulate the SCADA systems to disable, a key part of the Iranian nuclear program, right? So, and in the end, they succeeded. That's why we know it today. So, and the impact, I think, was enormous back then, and it extends right now and beyond actual initial target. And I think I was actually very curious to hear your perspective on that. So, from your point of view, how far reaching, do you believe like this impact has extended, and like what significant changes have happened, since the attack?
Yes. So before Stuxnet, the companies usually believed that if they isolate that network, if they take care of few vulnerabilities, like known vulnerabilities here and there, they should be good. But Stuxnet was the first example where attackers used a combination of seven or more than seven 0 days and gained access to those systems. So that brought up a whole new perspective that motivated attackers can also have resources and whatever means that they can get to just develop 0 days. And when you talk about SCADA security, SCADA systems, all vulnerabilities inside that system can have great impact. So that can compromise the security of those workers, people who live around that area, and whatnot. So it is believed that some nation state actors utilized those set of vulnerabilities and conducted the Stuxnet exploit. In addition to just attacking those PLCs, so any industrial world, PLC is kind of like a component that you can program on your own. So engineers can program PLCs to do, let's say, open up a valve, close something, control the pressure, something like that. And after Stuxnet, especially Mitsubishi, Siemens, a lot of those vendors have started looking into their own applications, their programs, and just basically looking more vigilantly for the bugs. So I believe that after Stuxnet, it's becoming more and more secure. So yeah, definitely it had good impact. Also,
Positive.
even after that, governments also started taking interest into deeper interest into securing their own critical infrastructure, and that's always a good thing, right?
Yeah. I mean, more attention to the security matters is always a good thing because it's not something that always happens in organizations and in the governments, as well. I
Mhm.
think we have a very different audience, people who are more experienced, people who are less experienced. And I think it would be also great, to take a step back and maybe if you can provide a very basic definition of the SCADA systems, what they're like, used for, to share it with them and give a little bit background.
Mhm. So in early days of industries, let's say electrical industry or manufacturing industry, everything was manual. So workers would have to specifically go there, set the space, program how step by step what would happen to each component of that pipeline. So let's say you're building a car. Each of those components would require a lot of manual effort. A lot of workers would put their life at risk to ensure that manufacturing is done optimized, right, in proper speed and everything. But after the age of internet, everyone raced towards making all those processes automated. So a lot of manufacturers started utilizing internet to control their processes. So that's where SCADA system comes in. So SCADA basically means that any component, any physical component that you can control programmatically. So most of those, so you can program a PLC, a programmable logic controller, to do a specific action. So let's say you want a production line to move forward. You'll just say, you just program the PLC to specifically take those actions at a set of times and combine that PLCs with multiple PLCs specifically designed for each goal. That becomes a complete pipeline. And yeah, that's where SCADA system comes in. So if you look at it this way, any piece of code, no matter how trivial, can have significant impact. So let's say there is a bug at some really obscure bug that won't affect normal computers, not normal anything. But if it goes into a SCADA system, risk becomes significantly higher. So let's say any system is compromised, or even system, and even if a controller stops working, it's directly associated to a physical device, and those physical devices are really huge and of course powerful. So that poses danger to what people to people around those devices and in the facility. So yeah, that's the importance of SCADA security right now.
Yeah. And I mean, I worked actually in manufacturing for more than like 2 years in my career and helped to develop, big controller components. So I know what, PLC is, but I think it's embarrassing to say, but I've never actually thought about the security aspect of it. So I think like the question is, how good do you think it is right now from the security point of view? And actually, is it hard to secure the systems?
Definitely, it's much more harder to secure SCADA devices compared to your normal devices. So let's take two different perspectives. A simple IT company who works in software and has normal attack surface. They have computers, they have mobile phones, and they have various servers. So they only need to worry about these three things. And these devices are highly researched compared to SCADA.
Mm-hmm.
You regularly get CVEs. A lot more researchers are into are actually looking for those vulnerabilities, and you can actually look for known vulnerabilities and secure your environment to some extent. But if you look at SCADA security, most of those applications you can't even get your hands on until you purchase a device. So let's say you want to find a vulnerability into a Siemens Step 7 PLC.
Mm-hmm.
To get the best chance of finding all vulnerabilities, you need to get your hands on that specific model of PLC. And if you find a vulnerability in that, that won't apply to anything else, right?
Mm.
So initial cost to acquire, initial efforts to acquire a specific piece of code or the hardware, both are needed, uh, is significantly higher in SCADA systems than to normal IT. So due to that, a lot of low-hanging vulnerabilities, a lot of easily spotted vulnerabilities are not even in the radar of normal security researchers.
Mm.
So that way, even when a motivated attacker or even someone who's just in a basement sitting, just trying to get their hands on whatever they can get, and if they start poking around the system, it's much more easier to find any bug in SCADA system compared to IT. So that's why even for the defensive side, it gets hard to prevent. So
are some of those connected to the internet?
most of those are not, but sometimes they just slip and get
Yeah.
on the system. So you can actually go to Shodan and specifically search for control system, industrial control system, and schedule enough they are available. And
Yeah.
some also say that they use default credentials. So uh, if you are
Yeah.
using one of those, please stop.
Kind of like security cameras and other of those devices that are directly connected to the internet, even if they should not be. But
Definitely.
tell me, Malav, tell me, like, it seems that those SCADA systems are connected to like huge cyber physical devices. They manage like electrical infrastructure, the power grid. They manage like all pipelines, water pipelines, everything. Those are very important. Those are a matter of national security. And at the same time, they're highly vulnerable because it's very hard to manage and fix the vulnerabilities on those SCADA systems. So do you think the solution can come from the government? Do you think this is a matter of national security and government should like create rules and regulations to enforce securing those SCADA systems?
Yes, so government should definitely take good interest inside each of those industries, look into the equipments and how vendors are securing it. So a shout out to US government for that. they
Yeah.
they after Stuxnet, they have surprisingly put up a really good set of regulations and rules that all those industries and companies operating within them should follow and comply with. So one really good project they have come up with, in addition to that, is a NIST advisory,
Yeah.
ICS cert advisory. So regularly, every month they'll just put up an advisory saying that we observed this CVs, this vulnerabilities, and this can pose this amount of risk. So
Mm.
basically, they are digesting security stuff and putting it into a small paragraph that executives can quickly digest and take actions and basically make their environment secure to latest and greatest of the threats. So yeah, good work going on that. I'm not familiar with any other countries implementing such measures,
Yeah.
but if yeah,
And do you think this is efficient?
yes, definitely.
Okay,
It's
nice.
better than nothing, but
Yeah.
there's still a long way to go.
Of course. Of course. And do you think like among the companies themselves or the organizations, because like it can have such big consequences if one of these systems is compromised, and especially from an ethical point of view, do you think they really like understand what is the risk? They take care of it, like they feel the need for securing and mitigating this risk?
Yes, definitely. There are also a lot of energy-related companies that actively try to look for those vulnerabilities and try to fix them. But
Mm-hmm.
sometimes it gets really complicated, especially when you put the CVSS factor into a
Yeah.
vulnerability. So let's say in IT, we have integrity, confidentiality, and availability, right?
Yes.
And that's due to those, we determined how severe a bug is. So mostly, if it's just doing some modifying some files, if vulnerability can only do certain limited things, it's considered classified as a low risk vulnerability.
Yeah.
But if you put that same vulnerability, same effect onto a SCADA system, then those kind of stuff, like those impact needs to be revisited, because even if you can modify even a simple flag or even a simple register inside a SCADA system, that can mean to a safeguard system enabled or disabled.
Yeah.
And that's critical. So
Like in the nuclear power plant, for instance.
definitely.
Yeah. Yeah, okay. So what you mean is like, even if technically the vulnerabilities can be the same or can be like very common vulnerabilities that we find anywhere, the consequences of the exploitation can be like huge, even if it's like a small modification in a small registry somewhere in a system that could otherwise be like very inoffensive.
Yes, definitely.
And if we talk, for our podcast is still very focused on application security, and if we talk about application security and SCADA systems, we can get back to the APIs, kind of the core what Malav escapes. So while APIs enhance the communication, do you think they introduce more security risks than benefits to SCADA systems? And what's their role? And actually, should we rethink, their role in critical infrastructure?
So benefit versus risk, I think should be evaluated on case by case basis. So it might be more viable to use APIs in case where you are not dealing with some really critical infrastructure. But most of those PLCs, most of those applications, so let's say Iconic Suite, it's a really useful tool that help you program PLCs. They have that API interfaces, so that helps programmers conveniently control their applications and control the logic, basically for a flow of program. But at the same time, it introduces a different set of attack surfaces. So whenever you are introducing APIs into your SCADA system, I think it should be evaluated on how much risk that is adding on top of your current SCADA vulnerabilities. So definitely, whenever you introduce a new API, it's vulnerable to whatever bugs or misconfigurations that rely on normal applications. So that's something to be evaluated.
Yeah, of course. And if you you know that at Escape we are very fond of open source tools. Like, we produce open source tools, we secure some open source tools as well. We are very involved in the community. Are there like open source solutions in SCADA systems, or is it only like proprietary from specific vendors?
Not that I'm aware of any open source tools for protecting those. So there are really critical challenges when it comes to securing SCADA, and it requires a huge capital to manage those, because all those applications inside the SCADA environment, all those management, PLC management, configuration softwares, programmers, everything is proprietary. So you won't be able to find any source code, and any way you can secure those, you'll need to get a better understanding of those proprietary softwares and applications. And that requires a lot of effort that I'm not sure you can always rely on open source community for that.
So you mean like following even cybersecurity research on SCADA, you need to be like involved already with companies that are actually using SCADA systems in production, and you need to like, do you have like, for instance, like targets or labs where you can try to hack into SCADA systems for trying, or is it only on live environments that you can do your experiences and your research?
There are really good simulators as well as labs as a part of open source project that you can locally set up and spin up various servers and test it locally. But that set of devices is sometimes limited. So let's say you are focused on a specific environment, specific industry, then you won't always find simulators for that application inside those labs. So sometimes it's a combination of using simulators, labs, and using actual devices. So
Yeah.
you don't need a complete environment to test. At the same time, it would be really helpful if you had a
Yeah.
physical PLC that is being used.
Yeah. Yeah. Of course. And I suppose that having like the physical environment is not very affordable for just testing.
Right.
Yeah. Yeah. I
Because some
get
of
it.
those devices also goes up to 50,000, 100,000, and
Yeah.
I don't think it would be possible to raise those
More.
Yeah.
fund.
Of course. Of course. Of course. And so for you, like as a researcher in the field, if we take a step back and we forecast what is the future of the security of cyber physical systems and SCADA systems, what do you think it looks like? Like, is the security improving? Is it getting worse because like the attackers are better and better at finding bugs? What does it look like?
It's always a cat and mouse game.
Yeah,
Even when it
of
comes to
course.
anything related to cybersecurity. But it's going in a good direction. Like either
Okay.
way, whenever we talk about cat and mouse game, we always say that attackers will find a new box. But we also forget that in that race, defenders will always prevent low-hanging bugs. They will always prevent script kiddies. So someone won't be just out there spraying,
Yeah.
trying to get something, and I think that's really huge protection. So you can always be secure. But at the same time, if you say that 99% of attacks can also even be stopped, and that's a good thing. So
Yeah.
I think that's the direction SCADA security is going towards. Governments is taking really huge interest, as well as cybersecurity industry is going towards that. So if you talk about Pon2Own or
Yeah.
ICS conferences, everything is going towards that. Yeah.
And do you think the vendors are like more and more collaborating with each other and also with the security researchers? Like, is there like a clear ambition to solve this security problem among the industry?
Ambition for sure, but I don't see companies collaborating for
Okay.
security, like
Okay.
providing security services. But
Okay.
I heard that a lot of security companies collaborated for getting to the bottom of stux and malware. So malware
Yeah.
reverse engineering, the amazing work for
Okay.
collaboration across the industry.
Okay. Yeah. And speaking about like the conferences, like um, if you want to like learn more about the state of the art in terms of SCADA security, what are the conferences that you should attend and that you should not miss at all?
So I'll divide that in two parts.
Yeah.
One would be highly technical and less technical.
Yes.
So
What's
if you just want to, sorry?
What's your favorite type?
What's your favorite type?
Definitely Pon2Own. Pon2Own it's a really good conference where they provide participants with actual hardware and give them live environment to test and develop 0 days exploits. And so one of those conferences, they had a Tesla car right on the campus,
Nice.
and whoever can hack that, they can take that home.
Really?
I love it.
Did you succeed or?
Oh, no, I'm just an observer.
It's a great hackathon idea, dude. I love it. I love it. Nice. And so if we had like so there are a lot of young cybersecurity researchers that are super excited about the security of cyber physical systems and SCADA system because like it's cybersecurity that has an actual real impact on the world, like on the physical world, and this is super impressive. If you had like an advice, a book and a tool to give to those young people trying to get into cybersecurity and SCADA security, what would it be? One advice, one book, and one tool.
One book, Hacking the Art of Exploitation by John Erickson. I
Okay.
consider that to be a Bible.
Yeah.
And
Do you have it on your
Sorry?
Do you have it on your nightstand?
Yes, I do. It goes over from really basic to really complex stuff. So even if you are really new to the industry, you can learn on, like, no matter where you are on the on your journey, you can always learn something from that book. It's a really old book, but still applies to a lot of concepts right now.
This is
One
a really nice one.
advice. Oh, have you read it?
Yeah, long time
Awesome.
ago.
Also, one advice would be to just network, meet the amazing people that we
Yeah,
have in this industry. You'd be surprised. Whatever little I know, 90% of it I got from pointers from other people. You can
yeah.
hear their stories, their experiences. So it's always useful. Don't spend money on buying courses, tutorials, but spend money on meeting people actually and conference. Yeah.
This is a very good one because we have like very often when we ask this question, we have a lot of advice that is very relevant about technical skills, and it is very relevant. Like to be good at security, you need to have like good technical skills. But actually, and this is a very good advice for young people. Like network is also something very important. Like cybersecurity is a community, and the more people you know, and the more ideas you share, the better you get at cybersecurity. So I really agree with that one as well.
Any of those conferences and meetups, like for example, there is a OWASP Bay Area going on every month here.
Yeah,
I can approach, or anyone can approach anyone and just can have a really great
yeah,
conversation. And even if you walk away after 10 minutes, you'd be wiser.
yeah,
Yeah, here it's the same. We're located. We're based in. Well, I'm based in Paris, and same. We have monthly of us meetups, and we're gonna actually organize one next month. So very excited
So,
about that. And yeah, the
yeah.
presentations and the workshops. I think our team actually quite often participates in workshops. So I think like we have 5 people that go there and exchange. It's super nice.
awesome.
Awesome. Well, thanks a lot, Malav, for your for the conversation today and for the feedback. I think it was very interesting for everyone to learn about SCADA system, their importance, and their potential challenges in the future. And really appreciate and having you today. And thanks for being on our podcast. And have a great day.